yes, good day, good morning, good afternoon, good evening to everyone that are watching, that will watch this session later. And welcome to one more episode of the Cloud Launch and Learn. I think it's really immediately I will start with the intro before I share who is our guest tonight. So I think in this digital era, with all of the stuff that is happening with AI, artificial intelligence, GPT, copilots, Gemini, and all the other stuff. Tonight, I think I would say we have a really a special speaker, lady speaker, and we have a really nice topic, especially for tonight. I really like also the topic. I mean, that is quite trendy. Can I say it like that? I think I can. So it's about scaling the generative AI and really building the multimodal agents on a systems on Google. That's really a nice and wonderful, in my opinion, and good for everyone that will watch, basically either now, either later. But before we get into it, I would like to give the stage a little bit to Niata. Niata, welcome to the episode.
Thank you, Martin. Hi, everyone. My name is Niyati. I work collaboratively in computer vision, multimodality, and multi-agent tech systems. And today, I'll be presenting you guys about how to build multi-agent tech system on Google Cloud and how to scale it. So,
Yeah,
let's get started with it.
indeed. Thank you, Niati. I will enjoy for sure because I'm really a big fan of this, by the way. And I hope that everyone will watch now, but also later they will enjoy also. So, Niati, the stage is yours. Basically, let me add this on the screen. Yeah, the stage. And
Yeah,
feel
thank you.
free, Niati.
Yeah, thank you. So, let's get started with it. So, today's agent going through agentic AI systems. What is the concept of it? How can we scale it? What is the architecture of the entire system? How can we collaborate different agents? How can we plan this different agents that we are collaborating? How can we design it? Different patterns, the workflow, and we'll go through one of the case studies. So when I talk about agentic AI system, what comes the first thing into mind is what are those? Like why do we need it? And what are those? How can we develop that? How can we integrate those agents with different tools and systems? How can we orchestrate? How can we host it into different platform and put it into the production? And how can we evaluate it, its quality? So and the operation. When I talk about the foundation, the multi-agentic system is more than one agent working all together. We can integrate it with different tools. It's called MCP tools that can be integrated with Vortex AI and including different implementation codes. We can develop it different. We can do the agent development with different Android development kit and different tools such as Vortex AI. And one of the things that we'll go through is health insurance agent or loan assurance, like how do the loan is being passed. The platform that we can use is Google Agentic Stack, that's Vortex AI, Engine. And how can we orchestrate that? How do different agent work through the protocol using different platform across multiple SDK and frameworks? And performance and the operations that we can scale through is through AI matrix operations and lifecycle management system. We can have three things to keep in mind when we talk about agent development kit. We can use LLM agent to use language model and the reasoning capabilities. It can be dynamic or flexible for decision making. We can use workflow agents that can work in different patterns. It can be sequential, it can be parallel, it can be a loop pattern. Third is a multi agent system that we are going to talk about today. that compose a different and specialized agent that collaborate and work together in a complex environment to achieve the complex goal. So yeah, how did we reach to the evaluation of the AI agent? So first of all, we had LLM with different prompt. Then we came up with RAG, retrieval augmented generative network. So that is LLM with a retrieval context. Then we came up with LLM and tools combined with RAG. Then a step further, that's called React agent, that combined all together LLM, retrieved context with reasoning and tools. And then we are talking about the multi-agent system that has more than two or three agents working together to achieve the single complex goal, that has LLM plus retrieved context plus reasoning capabilities and all the working tool together. So that can help us not only to interact with a different agent, but to different tools, systems, files, anything that you can imagine. So what makes this AI agent revolutionary? The AI agent are intelligent. It is an autonomous entity that you can imagine. We can plan and different tasks through that. The capabilities that they have is they can reason together, they can plan the different tasks, and they have a memory. So they can make a quick decision, they can learn, adapt it, and go back to the memory and make a very aware decision in real time. The reasoning capabilities gives that agent or whatever system that we are working on a logical analysis and decision making capabilities. The memory gives a context so that it can resolve the problem more efficiently from the past interaction and learning from it. When we talk about the planning, it can take multi-step strategy and goal execution. So it can just analyze what the task needs to be done. It can put it into different sequence and then strategize it and then execute the goal. The tools, the different tools that it interacts with. So it can take a system integration, a parallel task, or API connectivity. So when I talk about AI agent and their capabilities of reasoning, planning, and memory with the different tools to connect with the external world, let's say here, as this figure shows, we can have one user that interacts with the AI agent that has reasoning and planning capabilities with LLM. The prompt is being uh, offered into the LLM through users, and through that prompt, the system or AI agent will interact with the different tools, and that tools will be connected or integrated with global networks. It can be companies' data or profiles. So whatever the questions or the prompt is being generated through the system, it can interact to the outer world and gives us the relevant output accordingly. The critical consideration that we should take while designing and planning phase of the agentic AI is these are: we can understand the users and their functions. What do the user actually want to achieve by designing this task? Inputs and outputs. Whenever we clearly specify the input and the output with the different data to the agent in context with what we want to achieve and receive and the result we want, it becomes more clear to the agent to what to expect. The success criteria is something that can be measured in business matrix. So let's say we want to measure somewhere the capability of the system in a different environment, and we have different metrics that we are measuring, and through that it is eventually going to achieve the business matrix. So if we measure different parameters of that particular system, we can evaluate that, and according to that we can predict the business matrix, and we can understand that how the requirement that we have put is functional enough to achieve that business motives, or how effective our solution should be through that planning phase and the input and output. The tools and resources that we can use to achieve that is API, MCP server, model context protocol, data resources, agent development kit, Android development kit, and LangChain. So, to achieve this planning and design, let's get into the designing phase first of all. When we talk about designing and production, we need to take different aspect of it into the consideration. First of all is data protection, and second is safety and transparency. So while we are understanding the data protection aspect of it, we need to implement the access control measure. So whenever the agent want to access different uh, outer world or files, anything of that sort, we need to understand how the data will be protected when the user use the prompt to access this information through the profile or system, and how safe it is. Secondly, how transparent it is, how clear or maintainable that safety it is throughout this processing from prompt to the output. That's what we'll need to consider. And we need to also test and evaluate this framework. First of all, we'll understand the evaluation methodology. How the end-to-end output is being achieved is through different evaluation. We need to first define the testing approach. We need to understand how the tools will be selected in different agentic system, their performance, their trajectory, and how much the tool will be used, what will be the quality of it, the error handling aspect. Secondly, so when we talk about error handling, when the prompt is being made, we need to assure and ensure the agent that can handle a different kind of inputs that is being fed, whether it is valid or not, and it can read through the different error message. It can predict what should be the correct one if the error is being made, and the correct subsequent actions that it should take. The human feedback, whenever we integrate the agents into our system, we also need to give it a kind of human interaction in between whenever is needed, so it can escalate the process when the human interaction is needed. The agent, if the agent is stopped responding, then human can take the control. The prompt review, so whenever we are feeding into the system, we are asking the query, we need to give the system clear instruction. We need to define the tone, we need to kind of comply with the policy and alignment. If we are interacting with the different brands, we need to alignment with rules and inputs that varies accordingly. The feedback loop, so whenever the user whenever the system kind of collect the user feedback, it applies a different insight. Whenever the we reach to different output, it can give us a different insight into how the prompt is being processed through the system, and the tuning of it, the UX that it will uh, show, and reinforcement learning feedback loop. All of that needs to be considered in testing and evaluation of the framework through which we are designing the different agents, and the multi-agentic system. The most important aspect is context engineering. The context engineering is managing the AI model information. So basically, when we feed the prompt, it needs to have the proper context in order to find the output that we are looking for. It should save the information first of all and give the context video. We need to feed the enough context in which direction we want the output. We need to give the different keywords, different uh, efficient manageable system through which it can find those outputs and present it relevantly. The relevant is the most important aspect after the context. So that let's say, as an example, we are looking for different queries related to healthcare systems. We need to understand that the system or the agent needs to pull in the patient and their information, the overall aspect of the area or different information that we're needing through the system, and only that information needs to be processed in order to be relevant to the context that we are feeding in through each task that we want to perform. We need to compress the tokens. We have like number of tokens to retain the necessary information. It is very important to minimize the token usages. So we need to understand that how can we achieve the maximum output and use the token efficiently. The second thing is isolate the task. While we understand that each task is connected to each other, to kind of gain the complex output, we also need to isolate those tasks in order for the agent to perform specific task, and then integrate it with the different contexts. Let's say an example, if the data extraction is connected agent is connected to the data analysis agent, so then each agent needs to perform the task separately in order to achieve the output, and then it needs to kind of integrate both of those agents output in order to analyze how the system is going to kind of give the context and a different output accordingly the query that we have asked. Building and deploying agent is also one of the main aspect. Once we design and plan, we need to kind of consider three main aspect of it: runtime and services. We need to kind of select the services and runtime environment that it can execute the agent efficiently and reliability. We need to consider the development life cycle to manage building, testing, deploying, and monitoring the process throughout the agent's evaluation. We need to make sure that those agents interact with those interfaces efficiently, and for that we need to define how the user apps, other agents, and the systems that will interact with each other through API endpoints, A2A protocol, which is agent to agent protocol, and all other methods that we are considering for the system to interact with different agents. We can perform we can measure the performance and do the monitoring with response time, reliability mechanism, and effective metrics. So when we want to kind of define that how fast the agent should give us the output, we need to define the response time in order to determine the average what should be my average response in order to get the output from this typical queries that I'm assigning my prompt with. Reliable mechanism, it helps us kind of rate limit the handling of robust operation. And the effective matrix gives us the measurement of the agent performance against the existing process. So let's say an example, the existing task might be taking like 3 to 4 hours. We want to kind of able to predict and define through this effectiveness matrix that it should be able to take it like within 1/4 of the time that generally the manual process should take. So let's get into the architecture of the multi-agent AI system that can be developed in Google Cloud System. So when we talk about Google Cloud System, we have different front end system. We have different aspect of it or different module of it. First is a front end system through which we can interact with kind of system through a different loop or whatever the system that is being fed, the LLM input is being fed through this. So these front end aspect is being connected to the different agent. The coordinator agent is connected to the different sub agent. So let's say as an example, one aspect we are trying to achieve is a query which is like super big, and we need to break down this task in different sub agent, and that sub agents need to interact with the main agent that can handle or assign the task. So what happens in the system is this coordinator agent will analyze the sequence of the task. It will assign those tasks to the sub agent, and whenever the prompt is given, each of this agent will work together in order to achieve the single goal more efficiently than ever. We can use different AI agent. We can use different model. Here we are using in different cloud Gemini, and we have a deploying system through this. We can use either Vortex AI, Cloud Run, or GKE. So most of the AI developers that use through this system can go through different aspect of this architecture. The applications that we are using, application users that gives a prompt that feeds into the front end of the system through which we interact to different agents. These agents work together to achieve this output through defined matrix evaluation, planning aspect of it, reasoning, all of this, and then it will be fed into the model, and then it will analyze it and give the proper output, and then it will be deployed through this model runtime that we defined how we want to deploy it into the production. We can use different as an MCP client. We can use either database, API, or MCP servers. That's called a model context protocol. It can be different services or files through which this agent will interact, and then we will achieve those goals or tasks or the output of it. So, yeah, these are the main architecture components, as I told. First of all, is the front end through which the user interface running as a serverless cloud run services, different agents. So the agent can control the entire system, but also can be connected to the sub agent to enable the communication with agent to agent protocol. The agent runtime, so it will define how it can be deployed on Google GKE and then Vortex AI engine. Agent development kit is more about designing and deploying this AI agent and abstracting that complexity for the developers. The runtime that is defined through AI models that can help us find the and utilize those engines that we are using for inference serving. We also need to kind of take in account the MCP clients, servers, and tools through which we can standardize the agent tool interactions. So agent to agent tools, it can be two different system or two different apps that we want to kind of uh, go through. We want the system to interact with those two tools and then analyze the output, access through that external tools, and then access its database and files and give us the output. So that can be achieved through model context protocol, the client server and tools. When we talk about multi-agentic system architectural patterns, there are quite a lot through which we can achieve this permits through whatever the sub agents that we have designed. It can be, first of all, the coordinator pattern and dispatcher pattern. So let's say, as an example, the retail AI agent, where the central agent will analyze the request and the routes through the sub agent, and then it will interact with each other in order to support the based query that the user has asked. Secondly, it's called sequential pipeline. As the name suggests, it will go into the sequence of the sub agents. As an example, the healthcare AI agent, and then it will generate the summary through while going it through each sequence of the agents and submit the summary to the doctor. Third one is parallel pattern. So the parallel pattern, we are thinking about something like a workflow. So the workflow can be parallel, it can work parallelly. One of them can be defined as account history, users, different demographical data to get. So all of this can work parallelly in order to give us a result for the purpose that provides a comprehensive solution. The hierarchical task can also kind of a hierarchy that can define into the retail AI agent. Fifth one is review and critique pattern. Six is interactive refinement that can also be used in healthcare AI agent. And last is human in the loop pattern. So basically what it does is an agent that automates the workflow in order to process those output, but at each order that is given at a certain dollar amount, it also prompts the human manager to manually review that system whenever in order to improve or approve the transaction. So whenever the prompt is being fed for different financial system, then the retail agent will kind of analyze the task, but it also gives the control to the human in the loop to take the control when the actual transaction needs to be performed. So yeah, this is event-driven architecture that we will talk about for multi-agentic system. Here we have UI through which the client will interact. It can be LLM input that is being fed, that is being connected to different tools, as you can see here. And whatever the agent's task is performed, so each of the task will assign the event. So let's say, as an example, the agent needs to perform different task. Then proper event will be assigned to that in order to achieve that task, and that to subscribe to that event, we will use the PubSub and different Gemini, different models, Vertex AI, and cloud queries, database, the credentials, and the cloud services. So all this thing will come together in order to achieve the single output through the system that we are trying to achieve. So we can see that the user prompt and the front end, that will where the user will initiate the queries, and it will generally happens through the chat. The coordinator agent will receive the prompt in order to determine the approach of how the agentic flow should work through the queries that user intend to ask. The agentic flow execution, so it can be different patterns through which user will interact through the agentic flow execution. It can be sequential. Let's say the task has different subtask. Task A is, and that is like task A.1. The interactive is task B will interact with different files, different database, and it will give us the output according to the prompt that is given. Human in loop will basically give us the control to the humans whenever the system has a criticality in order to access different part of tools or system that we are using. And we also need to consider the response that it will generate so that we can validate the output. The response generator basically creates a file output, and through that we can perform the validation and checks. Building multi-agenting system with Google AI services. So we can have agent space, agent designer, and customer and engagement suite. These three things will work together in order to achieve the task that we are trying to achieve. So let's say, as an example, we have RAG, as we talked about, we have different data, we have different apps. It can be web, maps, or your data, and enterprise context. So all this data and tools will work together. We can build that in Vertex AI Agent Builder. We can use SDK. We can orchestrate and use the tools and models, the engines through which we can monitor the log. We can trace the output or the error or the operations. We can evaluate different example through the prompt is given. We can also schedule sessions and access the short-term memory through it. We can also generate or execute the code and simulation of any output. And we can see how the long-term memory is being accessed through this agent system that we have been building. We can identify the management and security and scaling through this entire agentic system. And through that, we'll use maybe like Gemini models. It can reason together audio and video streaming or any tools that we want the agent to interact with. So the key product that we and the tools of the Google Cloud technologies is Google Cloud Run, through which we will kind of run and containerized AI agent services. Secondly is Google Kubernetes engine that can be managed Kubernetes for scalable deployment as we want to deploy the multi-agentic system in a scale. Third thing is agent development kit that can be used for tools to develop, test, and plan and deploy those agents. Model context protocol that can help us interact with the different tools and systems. Vertex AI that can be used for ML platform to train and deploy the model. And it can also help us customize the different LLMs and the input and output and with the context that we want to feed. Model armor, agent to agent protocol, so that different agent can work together and communicate for complex output. Cloud storage, so we want to consider the scalable storage for agents to configure the data and model artifacts. So the logging, monitoring, and BigQuery is also a big part of it, through which we can understand that whatever the input that is being fed, what happened in each stages. So we'll go back to the log and we'll see that what the system actually performed and what each different agents has performed the task and how they analyze the data and the query that is being fed. So all of that is being done in serverless data warehouse for analytics and agent interaction histories. How do different agent collaborate? So there is one protocol that's called agent to agent card, where we can have different agents working together. How do they collaborate? Is they can have different skills that they can match. First of all, the capabilities is one particular agent is capable of doing different queries, and the other one can do other one. Let's say an example. The first one has capabilities to do streaming, and second one can push notification. So how do this work? How do these two agents can work together? Is they can exchange their functions, they can analyze their own task, and then they can interact with each other. The skills that is being um, achieved through this different agent. First one will give the description, the input and output, and second one will also give the description, input and output, and how do these two will interact with each other. We can use the same agent collaboration for retail AI agent to kind of access the financial data and do the transaction. Other one is interacting two agents that can be local agent through other agent. Let's say we have local agent being built in ADK or Vertex AI. So we want to interact with outside agent. Let's say we want to use model context protocol in order to interact with enterprise applications, and uh, we'll interact with local agent to enterprise application through model context protocol. But what about we want to integrate with two different systems? So that's where we'll use agent to agent protocol, where outside agent of the local agent will work to the other agent. That can be Crew AI, that can be LangGraph, that can be Azure AI, OpenAI, anything third party. So that's where we'll use model context protocol. So I want to talk about something that is why the multi-agentic system can transform the complex application. So, as an example, whenever the prompt is being given or fed to the UI, it can only interact with the memory and the context that is being fed or available on that platform. So, what if we want to achieve the same kind of complex output through different by accessing different system? So that's where we can use a multi-agentic system that can transform this complex accessing those complex applications. So we can break down the workload into the specified task in order to achieve the complex output. So independent agents can create kind of powerful uh, architecture, and that agents will interact with each other, not only the monolithic system, but also the multi-layer and multi-dimensional system through which the agent will work together to achieve and work together and get the output efficiently. We need to kind of understand and consider different part of it in order to achieve those or transform this output or complex applications. We need to consider modularity and maintainability part of it. So we need to kind of maintain the pipeline through which the agent works on day-to-day basis. It should be clean and understandable code base through which it can shift from monolithic complexity to multidimensional complexity. The system specialization. So the system should work in order for LLM to interact with different queries and specialized agents that work and interact with each other. The scalability, we need whatever we build that needs to demand the scalability part of it, so that in addition to kind of achieve the output, we can also scale the entire system and understand the bottleneck if there is any, and target the performance we kind of improve whenever we want to use this, and we want to measure against the past output or how efficient it was. The parallel development, whatever the agent system that we have built, we need to be able to build on top of it parallelly while the system runs through whatever that we have built. So these complex system needs to kind of work together and cascade the different agents that can help us achieve the development velocity, but as well as focus on the efficient performance part of it. One of the last thing that I'd like to discuss is use case. So let's say as an example, we are transforming the loan processing workflow. In order to achieve this loan processing workflow, we need to kind of consider the three things: loan processing officer agent. So through that, we'll kind of this entire officer agent that will act as a central coordinator in order to submit different loan documents. It can also give the different routes to the agent in order to perform the task, and that task will be given to appropriate sub agent. So that's how the officer agent will directly kind of interact with the sub agents. Second thing is document extraction agent. So what it will do is it will be crew AI based. So we can automatically process those submitted files that can be either income proofs, credit score, or bank statement. And the agentic system will kind of extract those structured content and validate the document and its authenticity and prepare the clean data in order to further analyze the process. Third thing is document analysis agent, which will be long graph based. So what it will do is it will analyze the structured data that we have kind of built through, and it will pass to the loan officer agent. It will identify different patterns if there is any, and it will extract the key financial and personal insight, which is necessary for accessing the loan eligibility. Fourth thing is loan decision maker agent. So loan decision maker agent will be ADK framework. It applies bank's distribution policy in order to make informed loan decision. So what it will do is it will evaluate the client's eligibility using the analyzed data that we have analyzed, and it will ensure the compliance with the financial rules. So we can kind of stop if any threatful activity is being done or accessed through user's profile for that. And last thing is human review and feedback. So that ensures a human oversight, and it remains integral to the part of the process, and it takes a financial decision on complex cases such as we kind of need to re-verify the user's information and continually refining the system-based feedback and creating the learning loop that can improve the user accuracy and the information that is being provided over the time. What we can conclude through all of that is the Google's agent AI ecosystem that can be powered through agent development kit and or development kit MCP and A2A, and that marks a significant leap in order for enterprise so they can design the intelligent and collaborative system that can empower different innovative and speed with a speed and precision based system. And it can also enable the AI agent to reason, communicate, plan, and coordinate with each other to kind of for the complex workflow, the task, or the different system that the local and other agent needs to interact to kind of fully automate, orchestrate, or achieve end-to-end process. And these kind of cloud infrastructure with open protocols and enterprises can also kind of help us move from monolithic or single system based intelligence to the dynamic and multi agent ecosystem. And that's what the future is, to kind of collaborate, connect, and build to the scale. And that's why multi agentic system built through Google Cloud is uh, it makes sense to scale it in order to have complex output to be achieved. These are the key trends. We can follow the personalization. We can help feed the system through more of the context and the memory. We can kind of make the system more and more enabled through different embeddings so that it can reason together through different modalities. It can be like speech, it can be images, it can be video, all of that. The system needs to be sustainable and efficient for those models to work and interact with each other. Multi-agenting system should also provide the privacy, preserving collaboration. So whenever the inside or local agent to work through the system which is outside, then it should ensure the data privacy for that. And all of this key trends can make a multi-agentic system more and more efficient and personalized. Yeah, I'll be happy to answer any question.
Wow, wow! I can say just wow, Niati, really nice presentation, a really nice topic. I must be honest; it was quite clear for me. I'm more on the other cloud, let's call it like that. I mean, I work already with agentic AI and all that stuff, but I'm on the other cloud now, to not mention or make a promotion. But I really like it, your presentation, first of all. On the Q&A side, I have three questions for you, but I see one question in the comment, basically from one of the viewers. So I wanted to ask directly. The question is basically, can we use open source LLMs?
Um,
Or what would be your recommendation? Let's call it like that, because open source LLMs is a quite broader, if I may call it like that. So there is a lot of LLMs now, models, and all that stuff. So maybe just what's your experience with uh, open source LLMs, if I may ask like that?
yeah, sure. So each system or tools or agents or source that we want to use has a different aspect to achieve. It also kind of I'll focus on what I want to get out from the tools that I want to use. So let's say we can absolutely use open source LLM in many cases, but that will be for like they can be best choice for the cost control, the transparency, and customization and deployment flexibility. If we want a different to achieve the different complex task and we want to schedule it, we want to plan, and we want to design how the system should analyze or perform those tasks, then that's where the multi-agentic system comes into the picture. Does it make sense?
Yes, it makes sense and it makes clear, to be honest. Really nice answer. I really like. Also, in the meantime, I have one or two questions. I said three, but maybe three will be too much. So I'm just thinking loud now while we are talking, and I think there are two in total. But in the meantime, while I'm asking the question, I can ask also the people that are watching this. Feel free to add your questions in the comment. Yeah, okay. Second question. Cool tech, quite active. Okay. Are there any explainable AI libraries preferred by GCP?
First of all, when you talk about library, yes,
Yeah,
GCP can offer a kind of set of AI and ML library.
yeah,
I would say that first of all, it can be Python SDK for Vertex AI and GCP.
uh-huh.
Um, there are like different docs of it. Vertex AI Python client library,
Okay,
SDK that you can use, and different things that you can use with that. You can kind of create, manage, and monitor and train those jobs um, for the model or agent to be performed. We can also use the pre-built AI service if you don't want to if you don't want to go for that route. It can be like vision language or translation,
yeah,
and we can achieve that pipeline through MLOps workflows.
yeah,
So it makes sense to kind of use GCP as your cloud platform and want to integrate those ML workflows with GCP
okay,
managed services. So it I would say that you can kind of set up this GCP project,
okay,
enable, let's say, create the project and use Vertex AI for that, install different SDK, and then authenticate and configure that, deploy that into the model. Let's say you want to kind of monitor the output and what it is iterating, and on the other way you can use kind of pre-built API or generative AI. Does it make sense?
yeah, yeah,
it,
yeah,
it
yeah, yeah,
yeah, it I would say it only make your intent to achieve what kind of output it is so easier if you know like What does your end goal look like?
Indeed, indeed. Yeah, it makes sense. I'm just thinking loud with you and just question. I'm a little bit with the puzzles of just thinking on what you said and then the question. But I hope that Kultech for you it's also clear the answer that Niati gave. So I meant CIA for the AI ethics, privacy, governance, not development. Okay, then you need to be more clear. Thank you. Yeah. Okay, so the idea is, AI libraries preferred. Is there AI libraries preferred by GCP, where you have, for example, any how it's called, any AI ethics, privacy, or governance? Does it have for the AI libraries, if I may call it like that?
That will be analyzed through different authentication while using particular tools or access of it or the library of it. So that needs to be authenticated. Yeah, I haven't used one yet for now, but generally, generally, if there is a data protection aspect of it
Yeah.
for the privacy governance, it should ask you to authenticate and why you want to access that. Yeah.
Okay. Okay. Yeah. Okay. Good. Thank you. Thank you, Niati. Yeah. For the others that are watching, also, I would say, yeah, put the question in the chat. Feel free. We have still some time, so we can catch Niati now. She is in the mood with speaking, so we can ask her some questions. In the meantime, my question, if I'm asked like that, it's about related to the model. I carefully listened to your presentation. As I said, Niati, it was really wonderful one. And for example, what I can't understand, for example, for myself, how do you decide when to use the fast versus the smart model, if I may call it like that, when you have multimodal across the agents? So we use a multimodal. So how do you decide which one it will be, for example, for this on that? To basically, why I'm asking, because usually what I have seen now in the last how long, couple of months, can we say like that, with all of this agentic AI that is happening, let's call it
Mhm.
like that.
Yeah.
So to keep the good quality first of all, but also the latency, because I see, for example, if we have a multimodal, one of the model is quite ping and giving answers, but the other
Mhm.
one thinking, and we know that
Yeah.
we use the same model. Let's call it.
Yeah.
Do you have any preferred or best practice, for example, what and how to be used? If I'm asked like that.
Yeah. So if I'm getting the correct question, what I
Yeah,
understood the way
yeah,
is like we just want to kind of understand why would the LLM or the agent would give in one aspect like fast answer, and in other aspect it doesn't take the query, or like it keeps on thinking. Or so what I can analyze is, first of all, when there is no subtask defined for the agents, it confuses the system.
yeah.
There is no pattern to think through, there is no reasoning model. So we want to kind of have a context in each and every part of the input that we want to feed. It should have the relevant data. The relevancy and context would play a bigger part. Why the same model will take different latency in order to give us the proper output is sometimes they are not personalized, they are not fine tuned
Okay.
for that particular task. So that's why um, I would say domain based personalization makes more different in order to fine tune those aspects. And uh, that's why there is a difference in between like using models through
Yeah.
prompt and using different agent through model. Does it make sense?
Yeah. The last one, the quote, I like it. That so it's quite clear. And thank you for that answer. And indeed, I fully agree on that one. And coming completely and connecting the dots with my next question, which is about, yeah, what is the recommended, if I may call it like that, GCP stack when, for example, for grounding the internal queries, internal data, data flows, engines, and how do we keep the how it's called? Yeah, how do we keep the retrieval, if I may call it like that, fresh and consistent?
Okay, so when you talk about different type, what is your end goal that you want to do, achieve?
Yeah, to create, for example, in this case, we are talking about AI. For example, I want to create, I don't know, agentic AI, or I want to create two different applications or chatbots that will use the AI models or all that stuff. Let's call it like that.
Yeah. So generally, if there is two different system, we should use model context protocol. Let's say we want to access uh, completely different, maybe like different chat or different video streaming
Yeah, yeah,
app.
yeah. Okay, okay.
So we can use to kind of connect the agent to that particular application. We will use model context protocol.
Yeah,
Um, in aspect of GCP native stacks, we can use Vertex AI Agent Builder that has like that will have everything that can embed, index, everything you can kind of search through. You can integrate the RAG. You can
yeah,
have infra connected to it and add-ons as well. It can
yeah,
have Gemini, open source Vertex, different tools, or anything that you can use.
yeah.
Um, yeah, all of that.
It's available basically, and I can use with the GCP basically in this case
Yeah,
as a,
yeah.
yeah, perfect. Okay. Yeah, I don't have any questions. I really enjoyed in your presentation. I must be honest, Niati. Thank you for your time. For the audience, I saw that Cooltech have some statement like popular, yeah, libraries like Lime Sharp and Sharp and all that stuff. So, yeah, thank you all for watching. Thank you, Niati, for giving a wonderful presentation one more time. And yeah, for the others that are following this channel, yeah, take a look on our YouTube. There is so many also other videos and wonderful presentations like this one today. And yeah, wait for the next one, basically, which is even everyone, it's something new where we all basically would like to learn something new also. So yeah, thank you all for watching and have a nice rest of the day, morning, afternoon, or evening. Bye bye all.
Thank you.
Thank you.